Hi everyone, let's have a look at prime factor trees. Prime factor trees are a very popular question in the GCSE exams. You are required to draw a prime factor tree, or you will be needing a prime factor tree when working at the highest common factor or lowest common multiple of some numbers. So let's have a look at a few examples and see what a prime factor tree is and how do we draw a prime factor tree out. Okay, so we're going to take the number 40. What I want is the prime numbers or the prime factors that go into 40, and when I multiply these numbers out I end up with 40. So I want all the prime factors of 40 that obviously multiply together to give me the number 40. So this is what we're going to do. Let's split 40 up. Okay, now we need two numbers that times together to make 40. It could be any numbers. I'm just going to go with 4 times 10. Now, is 4 prime? No. So I can split that up further. So give me two numbers that times together to make 4. Well, 2 times 2. Well, I know that the number 2 is prime, so I can circle 2 and circle this 2 here, and I stop there. My tree stops over there. But I haven't circled the number 10 because it wasn't prime. So I've got to split that up again. So another, two numbers that times together to make 10 this time. 5 times 2. Now I know that the number 2 is prime, so I can circle that. And I know the number 5 is prime, so I can circle that. And that's it, my tree stops because I've circled the numbers and I can't split any of the numbers up any further. Now watch what happens. We write this out as 2 times 2 times 2 times 5. We want the numbers in order. Can you see? 2 times 2 times 2 times 5. And watch what happens. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. We end up with a number that we started. So these are the prime factors of 40. They're the prime numbers that go into 40. And when we multiply them together, we end up back with the number that we started off with. Okay, let's have a look at another example. So I'm going to say, let's do the number 144, a slightly bigger number. So again, it's up to you. It's, you can answer this any way that you want. So we'll do this in 2 different ways this time, so you can see. So the first pair of numbers that come to my mind is 12 times 12. 12 is not prime, so I'll have to split this up further. I can do 4 times 3. 4 is not prime, so I need to split that up further. I know 2 times 2 makes 4, and I also know that 2 is prime, so I can circle that and that stops there. I know that 3 is not prime, so I'm sorry, 3 is prime, so I circle that, that stops there. Well, I can split this up, and what I can do is I can do 4 times 3 again. I just copy the exact same tree out because it'll work. 3 is prime, circle it, 4 is not, so 2 times 2. And the prime factors of 144 are 2 times 2 times 2 times 2 times 3 times 3. Okay, so let's work this out. Okay, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48, and 48 times 3 is 144, and that works. That's how you can check your answer, is if you multiply your numbers out that you've got at the end. If you end up with a number that you started off with, you've worked out the prime factors correctly. If you haven't, then it's incorrect. Now, what you could have also done is split this in a different way, but you still would have ended up with the same prime factors. So let's have a look. How else can I split 144 up into? Well, I know that 2 times 72 is also 144. I know 2 is prime, so I can circle that, but 72 is not, so I need to split that up. Well, I know that 2 times 36 is 72. 2 is prime, circle that. 36 isn't. Now I can do, I can divide it by 2. Oh, I know 36 is in the 3 times table, so I'll just do 3 times 12. I know that 3 is prime, circle it. 12 is not. 4 times 3 I'm going to do. 3 is prime, I'm going to circle that. And what I'm going to do is I'm going to split 4 up into 2 times 2. Okay, and I'm going to write this out in order. 2 times 2 times 2 times 2 and then times 3 times 3. And as you can see, look, you end up with exactly the same. So it doesn't matter how you split your prime factor tree up, you will still end up with the same prime factors at the end. Okay. Let's have a look at one final example. Let's try a different number this time. Let's try the number, let's do an easier one, 35. Okay. Well, 35 is 5 times 7, and 5 is prime, so I can circle that, and 7 is prime, I can circle that, and that tree just stops there. So the prime factors of 35 are 5 times 7. Okay. Lovely. Okay, now just going back at the top, I'm just going to touch upon something else. We worked with the prime factors of 40, and we said it's 2 times 2 times 2 times 5, which is fine, but sometimes you may be asked to write this in index form. That would be 2 cubed times 5. So your answer could either be this or this. Okay, let's do it for the next one, 144. So again, when we did 144, we ended up with this. If I was to write this in index form, it would be 2 to the power of, well, you times in 2 by itself 4 times. So 2 to the power of 4 times 3 squared, because you times 3 by itself twice. And then obviously this last example that we did, which was 5 times 7, we can't write that in index form because it's just 5 times 7. Thank you for watching.